This is part 2 of section 3.2. We want to graph a polynomial function. So we're going to follow these steps in order to get something graphed. Our first step is to find end behavior. We use the leading coefficient test. Which, if you recall, is this information right here. Basically, on our first step, we're going to get an idea of where we enter the grid, from the bottom left to upper right, or from the top on both sides, so on. Okay. Then we're going to find our x-intercepts and use the multiplicities to determine whether the graph touches or crosses at each one. That's basically what we did at this step right here. Okay. We're going to find a y-intercept. We will only have one because we're dealing with functions. If we have more than one y-intercept, we don't have a function. It doesn't pass the vertical line test. Okay, find symmetry if it has any. Now, what this means is you need to remember from the last chapter, we want to know whether we have an even function or an odd function or neither. And remember, even function means that we have symmetry about the y-axis, and odd functions mean that we have origin symmetry. Okay, we're going to determine the maximum number of turning points, and then we're going to graph what we have. We might want to plug in some other numbers to get a better graph, but in general, I'm more concerned with you getting a good idea of what your graph looks like so that you will know whether to trust what you've entered in a graphing calculator or not. Okay, so let's try getting this thing graphed. Our first step is to determine our end behavior, okay? The degree of this, making sure I have it in descending power order, my degree is 4. That's my largest exponent. And my leading coefficient is a 1. So my leading coefficient, which is the number in front of my largest exponent, is a 1. All right. Now for the leading coefficient test, our degree is even. So we have one of these two options. Our leading coefficient is a positive number. So my graph is going to enter from is going to rise on the left and rise on the right. So this is more what the computer is going to say. If we were having class in person and you had a written test, this right here would have been good enough for me, just indicating that you knew both sides went up. Okay, but this is more what it's about to say. So I know my graph enters something like this. It's going to come in from the top on both sides. Okay, now we need to find our x-intercepts. And that means I need to set x to the 4th minus 6x cubed plus 9x squared equal to 0. Now, unlike this problem here where it was given to us in factored form, in this case, we need to solve this by factoring, possibly using the quadratic formula. Basically, if it's not given to us in factored form, we should have the skills we need to get this factored. First thing I notice here is that I can factor out an x squared. And that gives me x squared minus 6x plus 9 equal to 0. And then I look at this and I need to factor this again. I notice that I have squares on either end, so I do a quick check to see if this happens to be a perfect square trinomial. The square root of x squared is x. The square root of 9 is 3. If I multiply these two things together, I get 3x, and then if I double it, I do get 6x. So that means that this factors, well, I still have that x squared, and then this factors as x. This is a minus, so this is a minus. The square root of 9 is 3. And that's squared, and that equals 0. So now I set each of these equal to 0. X squared equals 0, x minus 3 squared equals 0. And you know it, you don't need to solve these twice because you're going to, basically these are going to have, each have multiplicity of 2 because you're going to get each answer twice. Well, this equals 0 only when x equals 0. And this is essentially x minus 3 equals 0. Okay, well, technically what's happening here is I'm taking the square root of both sides. And then when I take the square root of both sides, I have plus or minus. But the plus or minus the square root of 0 is simply 0. There's not a plus 0 and a minus 0. Okay, that's why I just get to drop the squares here. And then this one gives me x equals 3. This has multiplicity 2, which means I touch here. This one also has multiplicity 2, which means I also touch here. Okay, part 3. Find our y-intercept. That just means plug in 0 for x. And if you look here, each of these has an x in it. So basically what I have is 0 to the 4th power minus 6 times 0 to the 3rd power, which is 0, plus 9 times 0 squared, which is 0. So this is 0. So my y-intercept is 0. Okay, so find symmetry. Technically what's happening here is what we do is we plug in f of negative x, do our work, and see if, if we get exactly the same thing as here after we plug in the negative x, then it's even. If I get exactly the opposite, basically where you factor out a negative, then it's odd. But also remember that when we were dealing with a polynomial in particular, it was an even function if all of your exponents were even. And it is an odd function if all of your exponents are odd. But if you have a mixture of the two, as we do here, then we have no symmetry. It is not even, it is not odd. Now it might have some kind of symmetry, but it's not symmetry about the origin, and it's not symmetry about the y-axis, which are the two I'm really looking for here. Okay. Part 5. This is nice when you get it. You don't often get it. All right, so part 5. Determine the maximum number of turning points. Well, the maximum number of turning points is the degree minus 1. So this is, our degree was 4. So the maximum number of turning points is 3. We don't have to use them all, but the most we are allowed to have is 3. And then our last step here is to get a graph. So I'm going to plug in all the information I have. I'm going to put it on my graph and then see what I get. Well, I know that it rises left and rises right. So I'm going to be coming in like this, doing some stuff in the middle, and then leaving this way. Okay. I know that I touch the x-axis at 0, which is here, and I touch the x-axis at 3, which is here. Okay? I know I don't have any symmetry, and I know that I have a maximum number of turning points as 3. Now, just a simple sketch, okay, of what I kind of expect to have. I touch here and here, so I expect my graph to look something like this. Because it comes in from the top, it hits this, and then it doesn't cross, so I know it turns around. But then I need to touch here again. The only way that can happen is if I turn around again to come back down, and then I go up to the top. Look at how many turning points I have here. 1, 2, 3. That's the maximum number I'm allowed to have. Okay? Now, if this were just, a paper test, this kind of thing would probably be good enough for me. But you might want to plug in some other numbers to see kind of, where this goes. And I plugged in some other numbers, like if I plug in, let's say, This is just sort of a side. This is extra if you want a better graph. Let's find f of 1. Okay, that means I'll plug in 1 for each of these, which gives me 1 minus 6 plus 9, which would be, what, 4? So f of 1 is 4. Okay, and then say I plug in f of 2. 2 to the 4th power is 16 minus 6 times 8 plus 9 times 4 is 16 minus 48 plus 36, which is 16 minus 48 plus 36 is also 4. So I have here. So this can kind of help you get a slightly better graph. It doesn't need to be perfect. I come in from the top here. I hit here. I have to go up to here. And then obviously I turn around at some point here. And I know I only have, I'm allowed a maximum number of turning points. So I can't turn around here and then come back up to here. I have to go above and then down and then back up. Now, most of the problems on the homework, you're going to be given a series of graphs to choose from as to which one could possibly be the correct answer. And it's going to be easier than possibly creating your own graph. Okay?